we've saw over 500,000 views in less than 6 months just on TED.com alone. It was picked up by over 50 other websites. And TED came back to us in about 4 months after the talk and said, you've seen over, your video's been watched by over 1 million viewers, which is at the it wasn't the very most viewed talk they've ever had, but it was right up there at the top. But they said, more importantly, you're getting more comments than they've ever seen. And they're very positive comments. And I needed to respond. So they actually worked with us to create a blog, which I hope gets posted on TED very soon, because we finally got it done, to try to answer the thousands of questions that have come across the transit on all of those 50 different channels. And the questions are wonderful. Thank you for doing this. What can we do to help, and how can I get this in my community? That's the answers we want, all of us want to be hearing in the world, right? So that's the reason I showed the TED Talk. I told the story quickly, but it proved to me that people out there listening, if you can reach them. So I thought, well, how unusual is this TED phenomena? So I wanted to compare it. Actually, someone in my company went back and compared it to other talks. And so as of 6 months, we've got over 600 million views. This is just on TED, 1,940 ratings. If you go on YouTube, YouTube is one of the 50 that have picked it up. And they do like versus dislike, so you can kind of see if people like the story or not. I'm pretty comfortable with the 99% like, but I said, does everybody like it, or they just don't even vote? So I said, well, what's it look like to other people in this space, other talks in this space? So we looked at both people that have done plastics, and Captain Moore did a fantastic job on making us aware of plastics in the ocean. Van Jones, I assume most of you in this audience know who these people are. They're much more famous than I am, that's for sure. Van Jones was the green jobs czar for President Obama for a while. John Doerr's the biggest venture capitalist in the world, probably. Kleiner Perkins, the most well-known. Bill McDonough, Cradle to Cradle, everybody's heard of him. And Al Gore, of course. So they've gotten quite a few views, but look at how long they've been on there. I hope I don't push the wrong button for the laser. And then we said, well, what about the like versus dislike? And what came out of this for me is if you tell a story that people are interested in, it will get watched. If you tell a story that solves a problem, it's about a solution rather than just talking about a problem, it will go viral. People are looking for solutions, which is what we all are looking here and we're all trying to offer. So if you propose more in the solution space than you do in the problem space, the message that I got loud and clear from this experience was that people are out there listening and want to help. They want to join the party. So why did I do this? I always get asked, why did I start this venture 20 years ago? Actually, I started in the plastics industry 35 years ago, believe it or not, out of engineering school. Well, I actually grew up in the 60s, so I remember this movie, the one word plastics. I'd always wanted to go back and figure out who put that in there, because they were very insightful, right? So this is the time period from the 60s till present day. The yellow, the top line up there is the annual growth rate of plastics compared to two other prominent materials that we use in our products, steel and paper. So plastics is outgrown, as we know, and that's why we're standing here today 4 decades later talking about this problem now that we've inherited. And in fact, there's more plastics in the world by volume than steel, just to kind of put it in perspective, not by weight, but by by volume. So there's a lot of it out there. I don't have to tell anybody in this audience about that. That's why we're here. And we know about the low recycle rate. I already talked about that, so I won't go into detail. And we know about the high value. So the green line relates to relative values, and these change all the time, but you get an idea that the plastics are more closer related to aluminum in value than they are to steel or paper. But yet their recycle rate is incredibly low. So again, the question, why aren't they more recycled? We focus today, and I'll talk at the end how we're moving it more into the plastics most of us have been talking about today, but in our history, we've mostly focused on plastic coming back from durable goods, computers, electronics, automobiles. And they just started coming back in large volumes. That was our fundamental problem, getting access to the plastics. But the real issue has always been it's not easy, as I discussed. And I wanted to put some more pictures to why it's not easy. So these are pictures of many of our sources around the world. So this is in Osaka, Japan. This is in Nagoya, Japan. This is an automobile recycler in Germany. a mixed recycler in Austria, automobiles and electronics. This is in the Netherlands, small domestic appliances. An electronics recycler in Germany, in France, España, Austria again. In fact, that's our joint venture partner for our plant in Austria. And in Switzerland, I always like this slide because the Swiss do it, they just do it a little bit more organized than everybody else. Surprise, surprise. South Korea, Taiwan, I could go on and on. I could show you hundreds of pictures because we have hundreds of suppliers around the world. Two things you should take from this. These are complicated waste streams when they come back. And you might notice that all of those locations were either in Europe or Asia, not North America, where we have more of this stuff per person than anywhere in the world. And I'll get back to that point in a moment and why that's so depressing for me. The good news is, at least in Europe and Asia, this stuff is being collected, it's being recycled, it's being shredded to small bits. They take a car in a 10,000 horsepower shredder and turn it into pieces the size of your hand in about 20 seconds. The metals are liberated then from everything, and the metals are recovered with magnets and eddy current sorters and other existing technology, and everything else that's left over is what's called shredder residue. This is from IT equipment. You see that they don't get all the metals, but they get the majority of them. This is from large appliances. You see why they call them white goods, because traditionally they have mostly had white plastics in them. And this is from automobiles. It's kind of hard to see the plastics in the automobiles, but we managed to mine the plastics even out of this waste stream today, commercially. So the big picture is there's literally millions of tons of durable goods that are collected and recycled each year around the world, but more so in Europe and Asia. They generate metals. This is a mountain of steel from one of our suppliers that's getting ready to go to a mini mill to make new steel. And they make mountains of shredder residue. In fact, that's Brian would know some of the people on top of that mountain. That's less limited. That's one of my investors standing on top of the mountain. They're quite happy to see that much material because that's what makes a recycler happy when they have a lot of material to process. So if you are one of these metal recyclers and you own one of these mountains, you have a couple of options. You can burn it, which has high financial costs, about a couple of $100 a ton in Europe, between 100 to 200, and high environmental costs if not done very well. Or you can do like we do in North America and send it somewhere else. It's not my problem, it's someone else's problem. Let them sort it out. Or you can go with the high-tech, clean-tech solution, which is where we try to fit in. This is one of our plants. This is how we receive the material. We receive it just like a commodity, just like a mining company would do, except we're doing it above ground instead of underground. We handle it just like a bulk commodity raw material. It goes into the first part of our process, which is, like the video showed, traditional recycling. Here's where we take out most of the things that are not plastic, and we recycle the metals. And even today, we're getting precious metals, and we're now looking for rare earths. And we're even now recycling rubber for the first time, because the automobile stream has so much rubber in it, we had to figure out how to do that. This is the more complicated part of the plant, where we do all the separations of the different plastics by type, by grade. Color is actually the easy part. And then we compound it into a pellet that is a direct replacement for virgin plastics. That's exactly what you would buy from a Dow Chemical, a BASF, et cetera. The good news for us, too, is now that we're making that stuff, we have a long line of customers ready to buy it. And they're ready to buy it both because we offer them an economic advantage, but the marketplace is rewarding more and more customers for sustainable and green products. And one of the ways they do it is through standards. Many of you in the room are probably familiar with the LEED standard for buildings, for green buildings. EPET, the one that I just brought up, is a similar standard modeled after LEED, but for electronics. In fact, I'm on the board of EPET, and we set standards for green electronics. And the good news is the U.S. government, which is still the biggest single purchaser in the world of anything, has said they will only buy EPET certified electronic equipment. And a lot of other governments, that's one thing the U.S. has gotten right. They like market mechanisms. They don't like the push mechanisms, but the market mechanisms, at least that's one thing the U.S. usually gets. And this has been a very powerful mechanism for us because it's forced electronics manufacturers to find PCR content, because one of the boxes that you need to check is post-consumer recycled plastic content. So this is what we call a market pull mechanism through a standard. Now, the only reason the standard has any teeth, however, is because the U.S. government passed a law that said government agencies must buy EPET certified equipment. So we're able to close the loop and satisfy that requirement for these types of manufacturers. And you saw a few of our customers. These are the types of products our customers make. We just make the pellets, they mold the parts. But we sell to some of the largest companies in the world, and we also sell to office products companies, as you see here. This company was after what's called the Blue Angel environmental mark. And not only are they getting an environmental credit, they're also paying less for our material than they would virgin. So it's a double win for them. And that's really where you have to be successful, obviously. Electrolux is one of the few companies, you've seen a few other name brands, but Electrolux allows us to co-brand with them and co-market with them because they're very proud to be working with us. And we're going in more and more Electrolux products. These are some examples. Electrolux is typical of the company that we start working with. When they first came to us, they said, well, maybe we'd like to use 10% recycled plastic and the rest virgin, and in a hidden part where nobody can see it, and if it breaks, nobody will care. We said, okay, we'll start there, but why don't you test it, at least test it apart, 100% our plastic, and see what you think. They did. Long story short, within less than a year, we were approved in 6 surface appearance parts, 100% our material, 100%. Those deck lids, those you might recognize who that manufacturer is. They won't quite let me say who they are yet, but I think they're the largest printer manufacturer in the world. Those deck lids and many of the other plastic parts, but the most prominent part is 100% our material. And this is what one looks up close. Getting this in a virgin plastic is nearly impossible. We're doing it with 100% our material. That's a mirror finish. Very difficult, but we did it. In fact, that's already out of production. That was in production for a year, and we're already on to new models. We don't ask them to do this. We ask them, oh, please put a texture on it, keep it dark, make it easy for us. But we managed to pull this off. So what about all the rest of the plastics out there? I'm sure some of you in the audience, okay, that's great, computers, electronics, automobiles, but what about all the stuff we've been talking about for most of today and the stuff that's going in the oceans? Well, let's put that in perspective. So what we're going after is the little tiny slivers in the upper left. 2% in electrical and electronics, 2%, what is that, 2 or 3% in transportation? Look to the right where it says packaging, and look at the bottom where it says consumer and institutional. So we're being pulled into that area now that we have separation technology that can separate different plastics from one another and also from other mixed materials. And this is European numbers, same idea. So if you take that factor first, what's the worldwide production of plastics? It's around 500 billion pounds right now. It's actually a little over that. And if you take the factor of 35% roughly plastics are used in packaging, and if you add the other fractions, it's over 50% of the stuff that's probably ending up in our oceans. That's more than 200 billion pounds every year that we consume. And most of it's not being touched, at least for a recycling standpoint. And in the U.S., in North America, the number I want you to focus on is that that's actually not just North America, that's the world. 70% of the world's exported waste ends up in China. There's nothing fundamentally wrong with that, but let me tell you the issue I have with that. And in the U.S., we export even more than the 70%. It's a much higher number that we export to China. In fact, we exported 100 million pounds, $100 million worth of plastic waste in a month to China last year. This is where it goes, and I've been to many of these facilities all over, and it's not just China, but China is the biggest market for it. And again, there's nothing fundamentally wrong with another country recycling a material. The trouble is they do it in ways that put the people at risk and put the local ecosystems at risk, and that's the problem.